Hey, what's up? This is Justin with Lesser Dog Tutorials, and this is a tutorial series on creating a Metroidvania camera system in Unreal. So what is a Metroidvania camera system? Well, it's a camera that confines itself to a room, can transition from room to room, and can be restricted within a room to better focus the player's attention on certain areas or prevent them from seeing areas that maybe we don't want them to see. A bit of a disclaimer, this is more of an intermediate level tutorial, so I'm not going to be going over the basics. I'm going to kind of speed through things, at least at the beginning mostly, to get to a point where we can start the actual camera tutorial. So let's get started. So I just created a new project with no starter content, and I selected blueprints. And then I created a root folder, and then in that root folder I just created a few folders to keep things organized. One for blueprints, one for textures, flipbooks, and levels. Then I created a new empty level and I saved it in the levels folder. So if you check in the description, there's going to be a link to this pixel art asset pack that we'll be using. The download button is down the page a little bit, it's right here. And you can pay what you want or just say no thanks, just take me to the downloads, which is right above the price. So I've already downloaded it and I've extracted it to a folder on my desktop. And in the assets folder, there should be two textures that we'll be using, the assets.png and the character sprite sheet.png. So just drag those into your textures folder. Then we're going to be right clicking each asset and going to sprite actions, apply paper 2D texture settings. This just makes the textures more crisp and not blurry at all. Next, right-click the assets.png again and go to sprite actions again and then go to create tile set. Then open the tile set and we're going to set the tile size from 32 to 16. Then we're going to need to apply a collision to the walls, floor, and ceiling. So just select colliding tiles so you can see and hit add box to each of these brick tiles. And when you're done, save and you can close it. Now right click the tile set and go to create Tilemap at the top and open that up, and what we'll be creating is kind of a simple room that we can kind of demonstrate how the camera works at the beginning. What we'll need to do is create a room that is the right size of the camera. So in our game, we'll be doing a 16:9 resolution. So the map width will be multiples of 16. We'll do 3, so that'll be 48, and the height will be 9. Then you can select the colliding tiles we made earlier and just kind of create a simple outline for the room. Next, in the layers, we're going to want to make 3 total layers. So the one that we just drew on can be called collision. Then create a layer that goes above that called foreground, and then make another layer below collision called background. Make sure you turn off layer collides for the foreground and background layers, but leave it on for the collision layer. Then set the separation per layer to 10. And you can save that and close that. I'm just going to rename my tile map to something a little less robotic, like Metroidvania 01. Change the camera mode from perspective to right, and change the view mode from brush wireframe to lit, and then you can just drag in your tile map. And I'm going to set the X location to 0, and make sure you set the Y location to 10. This is because the transform is located on the very frontmost layer. So if you bring that out to 10, then the collision layer, which is in the middle, will be right on 0, where your player will start. And speaking of player start, go ahead and drag the player start right into the level. And it's going to be really big, so we can just bring it down in its size to 0.1. And then if you just move it, it'll recalculate. And it looks like the image, the billboard is a little too large, so I'm going to bring that down to about maybe 0.25. Now for the character sheet, we're going to right click, go to Sprite Actions, and extract sprites. And on the auto sprite extract mode, that should be good. Yeah, that looks good. So it should be fine, just kept on auto. So you can hit extract. And then you'll see all the sprites kind of laid out. So we're just gonna make a couple flipbooks right now. Go ahead and grab sprite 8 through 15. And then right click that and hit create flipbook. And we'll just call this character run. Open that up and just set the frames per second to 10. Then you can select sprite 0 and 1, right click and create flipbook, and we'll call this one character idle. So open that up, and the frames per second are going to be a lot lower. We're going to go for 2.5. Now grab both of the flipbooks and then just drag them into your flipbooks folder. And let's go to project settings and let's search for bindings. And what we're going to need to do is add an axis binding. So click the plus and then it should add a new one and add in move right. And for the key, we're going to first select the A key and set the scale to -1. Since that will be the opposite of move right, and then add another key, and then we're going to do D, and that scale will be 1. Then go into your blueprints and create a new blueprint class, and you have to open up the all classes dropdown and search for paper character, and select that. We're going to name this BP _ Metroidvania character, and then you can open that. And switch from perspective to right, and from wireframe to lit. And then select the capsule component, and we're going to resize it to 18 height, and the radius will be 8. Then select the sprite component, and go down to the source flipbook and select the character idle. But the capsule component doesn't look right. Oh, okay. So the capsule height never changed. All right, so that's what 18 should look like. Go ahead and compile and save. And switch over to the event graph. You can delete everything that's already there, and we're just going to right-click and add in the axis event for move right that we made earlier. And then add a variable that we're going to call isMovingRight. And drag that out, and we can set that. And then you can just duplicate it and drag out from the axis value, and we're going to compare floats. And this is where we're going to decide whether or not the input is above 0 or below 0. If it's above 0, that means it is moving right. And if it's below 0, that means they're moving left. So we're going to add an add movement input function, and we're going to connect both isMovingRight bools to it, and connect the scale value to the axis value. Then we're just going to clean it up a bit. Before we leave, make sure that you select isMovingRight on the top, make sure the bool is set to true, and then change the world direction x-axis to 1. Now add a new variable that we'll call idle. And this is going to be a reference to the flipbook that we made earlier. And then create 3 more variables, and this will be for run, jumping, and falling. Now just by clicking the variables, you can assign the flipbooks that we made, so do that for idle and run, but we still need to make flipbooks for jumping and falling. So head back over to the main tab, and just right click sprite number 21, and we'll call that character jumping. And then right click and create flipbook for sprite 22, and we'll name that character falling. And you can drag both of these again to the flipbooks folder. Then go back and finish filling in the default fields for the variables. Now head back to the main tab, right click, and we're going to add a enumeration, which is under blueprints. And we're going to call this animation states. Open it up, and we're going to add 4 entries. Each one is going to be labeled the same as the flipbooks we made before. So idle, run, jumping, and falling. So save that and head back over to the Metroidvania character blueprint and add a new variable that we're going to call current animation state. And this is going to be of the type animation states, which we just made. Then we can add a new function, and we're going to call this set animation state. And this is going to be the function that we use depending on what the character is doing to set its current animation state. I just add a return node, and then on the input, I add a new argument that I'm going to call animState, and I'm going to set the type to be the animation state variable that we made. Drag in the current animation state variable, we're going to set it. Whatever we pass into this argument, we're going to set. And then we need to bring in the sprite and drag out from that and look for a function called setFlipbook. Link it up to the current animation state variable and the return node. And then right click and we're going to add a select node. And we can have the return value go to the new flipbook. And then this is where we're going to decide which flipbook to use. So take out the current animation state variable and drag that into the index, and then bring in each of the variables we made for the flipbooks and link them up accordingly. And there you have it. This function should switch the flipbook depending on what state we're going to be setting. So you can compile and save that. Now head over to the project settings and search for binding. We're going to add another input, but this time for action mappings. So create one and name it jump. And then we're just going to assign it to the spacebar. Now back in the Metroidvania character event graph, we're going to right click and add the input action jump. And from pressed, we're going to drag out and look for the function called jump. And on released, we're going to look for the function called stop jumping. Now we need to pull out the function called canJump, and we're going to branch from that to see whether or not the flipbook should change based on whether or not the character is grounded. So from the jump function, we branch out to see if that's true, and if so, we're going to set the animation state to jumping. And then after that, we're going to add a little bit of a delay and switch the animation state to falling. However, we need to make sure the character is falling first. So find the character movement is falling function, and we're going to branch out from that. And if it's true, meaning the character is falling, we're going to set the animation state to falling. Now we're just going to add a comment, and we're going to call this jumping, and we're going to turn it to black so it's a little less invasive on our eyes. Next, we want to make sure that the character is facing right or left, depending on its direction. So in order to calculate that, go up to the movement section, and at the end of everything, add a branch coming out from the isMovingRight bool. And if it is moving right, we're going to do the rotation. So if you turn off context sensitive and you search for set control rotation, that's what we'll be using. So after you find it, go ahead and duplicate it. And on each of the new rotation pins, we're going to split them so that we can only really rotate it on the Z-axis. So at the top one, it's going to be 0, but at the bottom one, it's going to be 180, meaning it's just completely flipped. And then drag out from the target because we need to get the controller reference. And connect them to both. And then just connect the input pins to the branch accordingly. Cool. So now the character should flip based on its direction. Now we're going to use the event tick node to determine what animation state the character should be in at any given moment. So the jumping situation is already figured out, but as for moving, we're going to do a couple checks. So first we want to say, if the character is falling, then we don't want to do anything. But if it's not falling, then we're going to set the animation state to be idle. However, in order to determine whether or not the character should be in the run state, we have to get the velocity of the character. So search for the node of get velocity, and from the return value, drag it out and look for the vector length. This is the variable that we're going to be really testing to see if there's movement. And if it's greater than 0, there's movement. If it's not, it's standing still. So bring out another select node, and you can drag the bool from the greater than node into the index, which will only switch between 2 possible choices. So if it's greater than 0, the character's running, and if it's false, character's idle. So just make sure you connect the select node up to the set animation state, and you should be golden. So now we're going to set a couple things in the character movement component. So select that and change the max walk speed to something like 250, and the jump Z velocity to maybe 300. And then the air control, I'm just going to do 1 so I can move around a little bit better. So back in the main tab, we're going to go add another blueprint in the blueprints folder. And we're going to select game mode base. And this is going to be named BP_Metroidvania game mode. And you can open that and set the default pawn to the one we created earlier. And make sure you compile and save that, and then go to your settings and make sure you assign this game mode to the default game mode slot. Cool. Now if you play, you'll notice that there's nothing, right? However, we don't have a camera, so if you eject, you can see that the player is actually standing there and the idle animation's running. So now we just need to figure out a camera so that we can get moving. So in your blueprints folder, add a new actor blueprint. We'll call this BP Metroidvania camera. So open that up. And I'm just going to add a sphere collision to replace the root. And I'll just name that root and drag it over and replace the original root. And I'm going to set visible to off in the rendering section. And then I'm going to add a camera. And then I'll add another component that will be a box collision. And let's call this player trigger box. Over in the construction script, we're going to add a few things here. Drag out the player trigger box, and from it, we're going to set relative transform. So create a new variable that will be called player trigger transform, and set the variable type to transform. Then add another variable called player trigger extent and change that type to a vector. Make them both public and drag in the transform variable and connect it to the new transform input. And then after the set relative transform, we're going to add a set box extent for the player trigger box. Should already pull it in. And drag in the player trigger extent and hook it up to the in-box extent. And so now those two variables are going to be what drives the size of the trigger box and its location. So select the main component, and if you go over, you can see under default, both of the options are there. So set the extent on the X to 128 the extent on the Y to 10, and the extent on the Z to 72. Then select the camera and change its projection mode from perspective to orthographic, change the ortho width to 256, and rotate it on the Z-axis by -90, and then pull it out on the Y by 200. And now it's facing where the player is going to be running around. You can compile and save, and now the camera should be ready to film stuff. So drag it in and try to line it up on the left edge of the tile map. You're going to probably need to set the snap size to 1 on the grid. And then just drag it, make sure it's lined up perfectly. And now, if you see how it's lined up perfectly, but in the little viewport, it's not really lined up right. That's because the viewport that we're using is elongated. So if you go to constrain aspect ratio on the camera, it should snap it into place and add black bars if the width of the screen is too large. Now, if you head back over to the character, we're going to add a new variable that we're going to use later, but we're just going to get it out of the way now. We're going to call it current cam and set the variable type to the camera blueprint that we made. And just compile and save that. And let's switch over to the camera and go to the event graph. And you can delete actor, begin overlap, and event tick. We won't need those. We'll just use event begin play. Then select the trigger box. And what we're going to need to do is add the event for on begin overlap. And this is going to be the thing that triggers the camera to work when the player walks into the player trigger that we made. So from other actor, we're going to cast to our character. And then as the Metroidvania character, we're going to set that current cam variable that we made. And the current cam is going to be this camera. So get a reference to self. So when the player walks into the trigger, it should set the trigger that belongs to that cam. It should set that cam as the current cam on the player. So go ahead and make a player controller node and drag out from that. And we're going to set the view target with blend, meaning we're going to switch to this camera. And then for new view target, we'll do a reference to self again. Now, if you compile and save, that should work, right? Because the character will be in the player trigger. Well, it does not work because the player spawns within the trigger and doesn't actually begin the overlap that's needed to switch to this camera. So, for the begin play, we'll need to cast to the player and then from the player, scan all of the elements that it is overlapping to see if one of them is the player trigger box assigned to this camera, and if it is, we can switch to that camera. So, first cast the character using the get player pawn, and then from the Metroidvania character, we're going to get the overlapping components, and we'll do a for each loop to scan through each element that the player may be overlapping. And from the array element, we'll see if the object is equal to the player trigger box of this camera. So if it is equal to this player trigger box, then we do essentially what we just did in the overlap section, which is set the current cam with a reference to self, and then set the view target with blend with another reference to self. So with that done, it should work, right? No, it doesn't work again. Why? Well, when the game starts, it's doing everything at once. So we need to wait a frame to make sure that the player's there before we scan for the player trigger box. So if you add a delay node right at the beginning with a duration of 0, it'll just wait 1 frame. And that should do it. And everything appears to be working well. Camera is in a fixed position. So the only thing to do right now is that if you go to project settings, you can see that the exposure, auto exposure was on. It makes things look weird, so you can just turn that off. and it should look fine now. Cool. And that should do it for this section of the setup of the Metroidvania camera system. If you like what you see, please subscribe and smash that like button into dust. I'll see you in the next tutorial.